good place to spend taxpayer money.
Is there a mute? Do I mute this or something? Just leave it?
Yeah. Oh, you. No, if you. I just set it off to mute it, and then. Yeah, goes to here.
Yeah, okay. Because we've been doing obviously without it.
Right. It works okay without it, but it's better with it.
Are we live yet? All right. You know, just do a pan, just do a slow pan so they see that we got a good crowd here tonight. Find a seat, folks, find a seat. It's 7:30, and you know what that means. Find a seat.
How are you?
Oh, good.
I tried to come earlier, but my father's in the hospital, so I got to run stuff over to him.
All
He's
right.
okay.
All right, understood. All right, so I'll just ask you about Kutztown and Jerry and all that, all right? The shop, or you don't want me to?
Oh, not Jerry. You mean Louis.
Louis,
I'm sorry. Okay,
Fucking
you're
Jerry, I call
confusing
him
me
Jerry
with
all
these
the
names.
time. Yeah.
I'm getting all mixed up here. Yeah.
Yeah, you're mixed up. Oh,
Are you
shit.
on the? I want to compare that to this last one.
Okay. Find a seat, folks, find a seat. You might even have to grab a seat. Yeah, we've got a nice crowd here tonight. Very nice. Okay, I want to welcome everyone to the September 13th, 2024 meeting of the New Jersey Antique Radio Club here in beautiful Info Age, building 9032A. Thanks for stopping by. Any new faces in the group? I don't think so. Just folks haven't showed up in a while, and I'm very happy to see everyone. And I think perhaps the advertised grab and go that our museum curator Ray Chase set up this afternoon has brought a lot of people over, and I do appreciate it. We've got seating room only. It's great. Thanks for coming. Okay, infirmary report. I really don't have anything on the infirmary report, which is a good thing. So again, if anybody knows of anyone that I should know about to report on, please let me know. I happen to notice that none of us are getting any younger. So, you know, we're all going to show up on that report eventually. So just let me know. All right, on to old business. On Saturday, August 24th, we held our summer repair clinic here in building 9032A. As I wrote in the Jersey Broadcaster, we were light with experts, but we all had a productive day, and everyone helped each other out, as they usually do on different projects. And of course, the radio bagels and radio pizza, well, they were all gone as usual. Disappeared quickly. You can see that video thanks to our videographer on YouTube, Radio Wild. Where are you, Radio Wild? There you are. Thank you. And thank you for making the video, too. So check out Bob's video, YouTube channel, Radio Wild. All right? Any comments about the repair clinic, please? What do you got? Anybody? Anything? Anybody? Nada? Niente? It is, I always make this mistake, but I won't make it again. It is October 26th. Make sure it's a Saturday. It is the Saturday. Because I told some disinformation, fake news to somebody, and I said it was October 24th, only thinking because our August one was the 24th. So that was wrong, and I regained my confidence and realized that it was the 26th because that's a Saturday. So we had a great time, you know. If you need a repair clinic appointment, please let me know. Well, let me know soon. That's it, yeah, because it is coming up. Just send me an email, radioricardo61@gmail.com, and I'll put you on the list, okay? And again, it's commensurate with how many experts we have. So, you know, if I can't fit you in, don't feel bad about it. It's just that we don't have that many experts available. So, okay, we'll move on. New business. Well, let me go back to docents. How are we doing with docents, Harry?
Well, we're doing all right, but our docents...
Harry, stand up, please. Harry, stand up, please. You're talking to the back of James' head.
Okay. Our docents aren't getting any younger, and we are always looking for volunteers to become docents. And we're going to the public for volunteers too, and haven't gotten any yet either.
Yeah.
But we will, because we have to. Our current docents have been doing great. They have been stepping up and filling in, and so on.
All right.
So,
And of course, all the docents that we have, we thank them so very much.
yes.
Obviously, we can't pay you, but we guarantee you a high place in heaven, every one of you.
And you get to show a great museum.
Okay.
So we're working on it.
All right, thank you. And I know we're getting busier, right? The RTM's getting busier?
It was extremely busy through the summer in particular. Quieted down this past week a little bit. So we'll see how it goes.
Okay. All right, new business. And very new business. As was advertised on our communicator this afternoon, the RTM curator, Ray Chase, opened up the Excess Take electronic vault to our club members as a grab and go. So if you were here between the hours of 5 and 7, you got to see a lot of stuff. And I took some photos of the people that were grabbing and going, and I also took some photos of the empty shelves. So I think we did pretty good. Ray, yes, we did pretty good? All right? Oh, Ray is shaking his head. Yes, we did pretty good. So that's a good thing. And I also grabbed and gone and got stuff, so that's good. All right. So there should be cubic feet of storage left over for more stuff. Any comments on that? Did everybody get something? Raise your hands.
2 hands.
All right, all right. That's how it works with us guys, I know. So.
Let's give Ray a hand for putting this together.
Ray, you need a hand. Good idea, Bob, thank you. Thank you. All right. All right, more new business. InfoAge is having their annual Wall of Honor Awards dinner Saturday, October 5th in the Marconi Dining Room. I believe everybody should know where that is by now. Any club member is invited to the event where former scientists and military personnel who worked at Fort Monmouth and here at Camp Evans are honored with a commendation plaque, okay? It's a suit and tie affair with a dinner and cocktails. There are reservation applications on the entrance table right there. It is an InfoAge fundraiser, so the cost of the event is a donation, okay? Is it cheap? No, it's $100 a head, but it's well worth it as a donation. We're helping InfoAge, the mothership of where we are right now. You know, we are one of the 11 members of InfoAge as clubs, so we need to help out our mothership. So if you can do it, please do. I will be there. It's expected that club presidents attend. They call it black tie. Maybe 2 people wear black tie and tails, but I just go in a suit. And of course, I'll be handling the A of the AV, and hopefully Dave Seeker will be handling the V if he can make it. So we hope to have him doing that also. He's been doing it. How long have you been doing it, Dave?
I missed the first one, but I've been at every one since then,
What is that, like 10?
at least.
Right? Yeah, yeah. And he's archived everything. So if you want to go back and watch from 10 years ago, all the awards given out and all the dinners given out, you can do that if you really want to. Okay. Okay, we covered that. Any other new business anybody wants to talk about? Any other new business? Oh, yes, there is some new business. Come right up, AKA Bob Bennett, or should I say AKA Radio Wild. Stand next to me so I don't have to take off my pendant.
I just got this my crib notes here.
Okay.
All right, folks, I don't want to take up a lot of time here, so I'm going to do this real quick. Back on August 22nd, I sent an email out to the club. And this is kind of a conceptual thing I had. I thought it'd be a fun thing to do at the Christmas party this year, have a game. And I kind of self-titled this game. It's called Know Your NJARC Member. And this would be based on actual life events that you may have occurred at some point in your time in your life. Not bad things and not gross things, okay? But things that might be cool. Like, for example, I just made up an example of the game. So what would happen is I will read off something that happened to one of us. Then you have 4 choices, A, B, C, or D, with the name of an NJARC member. You pick up the letter, circle it, whatever, and then we just go on to another question. So what I was hoping to do was to get input from all of you into my inbox, and I could start piecing this thing together. Well, after I sent the email, I only got 1 response. So,
And that was from his wife.
All right, so I'll just read off an example. Let's see. This NJARC member once won a pint eating contest, then interviewed as the new winner, burped into the microphone. Was it? You know, that kind of thing. That was just an example. This is total fiction on my part. So what I'd like you guys to do is, if you have a little extra time, I know some of you are busy and I get it, all right? But I think this would be fun. If I could get like maybe 8 or 10 good responses, and you can send me as many as you want, okay? I'll filter them out and figure out the best ones to put in. And then the winner of this game, there'll be a radio-related prize, and if there's an event of a tie, there'll be a tiebreaker question, okay? So send me something that happened in your life, if you have the time to do it. Send it to my radiowild67@gmail.com account. Okay, I want more than 1 response. I'll take responsibility for this, and I think this will just be a lot of fun to do at the party. So if you could just do that for me, I'd greatly appreciate that. Thank you.
Hey, Bob, why don't you put that out on the communicator again a couple of times, you know, before December.
Oh, so if at first you don't succeed, keep on sucking until you do succeed?
Yeah.
Okay.
The other possibility
Thanks, everybody.
is lock the doors and nobody leaves until he gets them.
Okay. All right. Okay, anything else? Anybody else want to say anything before we move on to our ham shack corner? Okay. All right, so, not to get into the weeds on this, but the CEO of ARRL, David Minster, yeah, wrote in this month's QST how the ransom hack of their LOTW, Logbook of the World, was fake news, or at least exaggerated, and no mention of any money paid to the hackers. All right, you guys who know better than I, do you know anything more about that? I understand $1 million ransom was paid out to that. I'll bet Matt Reynolds has something of interest to tell us about that.
If it was me, I wouldn't be here.
But what do you think the problem was? Come on up.
Not enough money spent on IT resources, probably.
Well, why?
Not enough separation between systems.
Well, come up and just mention it, please. Come. Come on up. Well, you're the smartest IT guy in the room. Or at least you're the youngest guy, smartest.
I don't know. I don't work for them. I'm not speaking for them, but I am an IT guy, and it just highlights the importance of patching your systems and keeping things compartmentalized, so if something in your life does get compromised, that you don't lose everything you have. You know, so don't put your taxes and everything on your cell phone and leave it in the toilet, you know, or something like that. You know, keep systems separate.
Why did he start out by saying fake news? Did this really happen?
It did happen. ARRL.
If on the second page of the QST, they sort of gave an explanation, and it said nothing about a ransom. They just said it was a screw up. And then everything around this, I hear they had to pay a ransom of $1 million.
Did they have $1 million?
They negotiated
What was that?
cybersecurity insurance.
Oh, what do you mean, insurance? Yeah.
Big companies have nowadays cybersecurity insurance when stuff happens.
Yeah.
So that if it happens.
Well, I've heard all sorts of different ends of it, and that that QST is not doing so well, ARRL is not doing so well, The Current is not doing so. On the Air magazines aren't doing so well. So I don't know.
I think they negotiated it down because they said that what they stole didn't have. They couldn't resell enough of what they stole or whatever. Like they didn't have credit cards or something of value.
All right, I'm sure more will come out about it, but obviously it's in their own publication, so they're not going to condemn themselves. So you know.
They were probably minimizing it to do damage control.
Right.
The hackers must have been really disappointed when they found out they had the information from the cheapest people in the world.
Amateur radio guys are the cheapest? Oh, I thought it was the antique radio collectors were.
Part of it was they didn't have to explain it was a 501c3 and not a corporation.
Yeah, yeah.
Hey, Rich, we might be cheap, but we're not criminal.
Not yet.
There's one thing to keep in mind a lot of times. I don't know.
Speak up, Bill.
The IT insurance, okay? But I know about liability insurance, like for my corporation.
Sure.
If we pay out $100,000 through the insurance then raises our rates exactly $100,000 for the next 5 years. They get their money back.
They got to make it back somehow.
They loan you the money to pay for it. So we always think insurance covers everything, but for a lot of companies, like our small companies, if we ever had to pay out a lot of money, we go out of business because we couldn't afford the liability insurance to pay all, even though the liability paid for our liability. I don't know how that works with IT, but I have a feeling it's the same thing for the insurance.
Well, I could go through it a little bit. We're going through it at work. Basically, companies that offer security insurance will evaluate your stuff to see how vulnerable you are, which will impact how much they're paying.
That would make sense, yeah.
Leaving out stuff and aren't patching stuff, they'll give you a laundry list of stuff to fix or tighten down on, which will lower your rate.
Okay.
Because we're going through that at work.
Darren.
I want to add something to that business about liability insurance. So when you have a major payout in a particular area of liability insurance, they don't just raise your rate, they raise everybody's rate
Yeah.
who's in that area of insurance liability.
Yeah.
So in the state of New Jersey, you know, certain obscure types of insurance, there's only a handful of companies that sell it. So if you're running estate sales or auctions like that, you have to buy insurance from one of two companies. And if anybody's gone to some of these estate sales, some of them are run really irresponsibly, where you have stairs falling apart and live wires hanging out of the ceiling, there's a lot of, and they don't set the houses up in a safe way. Well, about 3 years ago, a company up in North Jersey had a major trip and fall over a broken stair, and everybody's insurance doubled. Doubled, because one person won a ridiculous. It's not just the one company, it hits everybody.
Yeah. Well, since you're on the line, so to speak, do you want to tell us about what's going on with your end?
Have Darren come up. He made me come
Yeah, yeah, yeah. Darren, come on up.
What's that?
Come on up. When you gave me this, doesn't that mean to stop talking? All right, there's things happening at K-Town and with JD Auction Services.
Well, there's things happening everywhere. Interesting age. So obviously, I'm sure everybody's aware that there's a little tiny radio swap meet next weekend, not tomorrow, next weekend, Thursday, Friday, Saturday, in Kutztown, Pennsylvania. That's the DVHRC Fall Kutztown. It's actually the 50th Kutztown. So it's the 50th, not the 50th anniversary, but it's the 50th Kutztown meet, since it's twice a year. And we will be hosting the auction on Friday night, Friday evening. And there's going to be a lot of interesting stuff at that auction. We have some estate items from Louis Newhard's estate. If you don't know him, Louis used to run, and he was the proprietor of Kutztown Radio, which was the antique radio booth out at Renninger's. And there was a lot of speculation that Kutztown Radio was going to be no more, since Louis is no more. And so that is now being taken over. We will be taking over Kutztown Radio. So that will continue to be a fixture at Renninger's. And it will be staffed by somebody most weekends. So that will continue on, offering restored items for sale, repair services, and probably in the future maybe some restoration parts sales. In addition, we have an auction scheduled for October 12th down the road a piece in Jackson at the firehouse, where we normally have the auction. That is actually posted, and we'll be pushing more information about that out in the near future. But mark your calendars for October 12th. It's a Saturday, and that'll be another great auction. And so that's what we have coming up. And the Kutztown auction is going to have some very nice items. There'll be lots of tubes, lots of radios, some hi-fi gear, and the October auction will have a lot more radios, tubes, and lots of really nice hi-fi gear. So there's some good stuff coming up, and I hope everybody marks their calendars and gets their cash reserves ready.
Well, one out's great, man. I just put it in my phone.
Oh, well, there you go. That's the easy part, right? You're ahead of me. So, hope to see everybody out at Kutztown, not just for the auction, but if you haven't been there, the swap meet is probably one of the best in the country. Certainly one of the best in the Northeast at this point. It's really a sight to see. I mean, it's 2 whole pavilions now, and plus you got the auction, and it's always exciting, even if just to see the stuff that turns up there, because you never know what's going to turn up at Kutztown.
If you haven't done it yet, put it on your bucket list.
And the radio bonfire is always a fine send-off for some consoles that are past their prime. So.
Thank you, Darren. But there, you know, when Darren's talking about the, I call it the Viking funeral to consoles, and you know, the burn, and some of the years it seems to get the lineup seems to get longer and longer. And of course, anybody who wants that console, come and get it, or parts of that console, come and get it. There are people who cringe at the idea that somebody could possibly burn that part of history. But yet, hey, you know, we know that stuff's just got to go. You know, we just know it's got to go because nobody else wants it, and it makes for an entertaining evening. Okay, all right, thanks so much, Darren, for filling me in on that. And of course, with what's happening in Kutztown. I will be there as a vendor. How many vendors are going? Whoa. Just 3 of us, eh? How many buyers will be there? Or people perusing, should I say? Or people going there intent on not buying anything. Yes, that happens. That happens. It happens all the time.
Boy, wait till I sit down for a confessional, huh?
Okay.
The nice thing about Kutztown is that you really don't have to worry too much about the rain.
Well, I got a message from John Cummer that he's already looking. He's already telling me, John Cummer emailed me a couple hours ago that it may be raining. There might be a chance of rain. So he likes to play Uncle Weatherby.
As a Kutztown seller, as a vendor, I can tell you that it seems that when it rains in Kutztown, the sales pick up.
Yeah, it did the last time. You're right. You're absolutely right. Okay, let me continue with Hampshire Corner. Of course, we know that AWA convention in Henrietta, New York is October 1st to the 5th. Bill, will you be going? AWA convention, you will not go this year? Okay, all right. Anybody else going this year? Ray's going. James is going. All right. John. All right. Okay. I don't know if John Cummer's going. Do you know? I didn't ask him actually.
I don't think he will.
Yeah, he might change his mind. He changed his mind. Would you be willing to bunk with him?
Hello? Sorry, I thought never mind.
I believe you're probably going to get feedback right now because he's watching. So, okay. All right. Next, we have the Wayne Radio Amateur Emergency Team, and that's September 14th, which is tomorrow. That's at Tinton Falls, the Garden State ARA. That's Tinton Falls, and the Garden State ARA is September 28th. And I received a notice for the Nutmeg Hamfest, and that's Sunday, October 13th at Maloney High School in Meriden, Connecticut. And you say, oh, come on, Rich, come on, it's way up in Connecticut. I've attended that a couple of times, and it's a really good Hamfest. It's a really big one, and I've always come across with something good and interesting. And it's a nice ride up there. Okay, all right. All right, so I will be taking reservations for our next fall Hamfest Swap Meet show, and that will be PAL, Parsippany, New Jersey, and that will be November 16th. November 16th. So I'll let people know, but I will be taking reservations, say next month, the beginning of October, okay? Our fall show is usually our biggest show, so get your name in there quick if you're going to be a vendor. Really appreciate that. All right, any other news, any other Hamfest news you'd like to talk about? No? Okay. All right, after a brief intermission and sale of our 50/50 tickets, which Darren and our Vice President, Paul Mondock, will be taking your money for, we will have our special presentation, maybe a preservation, yeah, by our very own John Stoll from south of the Mason-Dixon line, way down in Virginia, okay? And he will be giving his presentation entitled, "The P.T. Barnum of Electronics, the Tube Checker." What does he mean by that? Now, you know, when he gets up here, you can ask him that immediately and throw him off from his presentation. But anyway, he spent a hell of a lot of time on the road to come up this evening to give us his presentation. So be nice to him. He hasn't drank anything, he hasn't eaten anything, he hasn't slept. So he's in bad shape, basically, but he'll do the best he can, okay? So, short intermission, 50-50 sale of tickets. Come on up, guys. 3 for 2. 3 for 2, guys.
When I give you the presentation, okay, if I'm starting to run late, let me know.
Well, I'll do what he did to me, not like that. I said, what is that? You stop talking?
Well, there's like a couple of later sections that I could jump over to shorten it up.
Well, I mean, perhaps you know that we like 45 minutes and then 15
Yes.
minutes of Q&A.
Yeah.
Because, you know, because there's a snooze effect. And we got some showing tonight. We got some showing. It's great, man. It's great. You bring them in. You bring them in.
Oh, only one time. Once they hear the presentation, they go,
Oh! Thanks for coming.
Oh, yeah. Prince is just a haul for me usually, but he gets a haul for you too because you come from there.
82 miles.
What?
82 miles to get here. One way.
Yeah,
I do it because I love it.
I know.
Electric is my life. So,
For the repair clinic. An old amplifier, is that
tube?
Tube.
Sure.
And what email do I send it to?
Radio Ricardo.
Oh, let me just get this here. And of course it's
61 at gmail.com.
Okay, I'll do it this way. Radio Ricardo at 61 at gmail.com.
Yes.
Okay. I got to figure it out because it's
Okay.
okay.
You going up Rochester?
No.
It's just holidays this year.
No, it is. I forgot. You're right. Yeah.
But next 2 years,
Did they do it, huh?
I'll be there. I tell you,
Does that affect them up there?
I made last year, and the year before I couldn't make it because of that. So I sent Bob Hobday an email.
Is he Jewish?
No, I don't think he no. So I sent him an email. I can't make it for the holidays, and maybe they could take that into consideration when they reschedule the conference. He wrote back to me, "Sorry, Bill, we'll miss you." But I got
Sorry, Bill, convert.
I got a letter from the VP,
Wait a minute.
the VP this year. I forget who it is. Asking I was going to be there to take pictures. I said, "Sorry, no." But, George Savini came to Westlake yesterday, gave a speech.
Oh.
Talking about Iron Dome and.
Oh, yeah. Oh, that's great.
I got nothing but compliments on him.
Well, he's a good speaker. He's a good speaker.
And there's a big Jewish population there,
Of course,
so,
yeah,
so they ate that stuff up.
Why don't I get him here? Why don't we get him here?
Oh, he's amazing.
You know, I should do that. Especially talking like that.
Yeah. And he can get technical. Sometimes some stuff got one over their head.
Well, here, the technical will be all right.
We start talking about KU band and gigahertz and.
Well, to be expected.
But, So, I'm trying to think. I'm not sure about the clinic. That might be when I'm in Europe. Because we're leaving October 12th for Europe, and we're there for I think like 12 days. I'm not sure. So I'm not
Okay.
sure. I'll get back to you if I'm going to be here or not.
Well, it'll be the 26th.
26th?
So, 26th.
I think we'll be back by then.
Saturday, 26th.
I think we're back, yeah. So, it's nice going, but I'm a homebody. I'd rather be home.
I like to travel.
Vacations are nice, though.
I mean, when I was younger, I was, I had a real wanderlust, and it was good because my father worked for Pan American Airways, and in a construction division. But he was, as a family member, I got to travel for.
Well, that tape recorder picture with Erwin Sobelman, he was dating somebody back in the 80s, and they worked something in the travel industry, and he got a trip to England on a Concorde for free.
Whoa, that I never.
3.5 hours.
Yeah, can you imagine a rocket ship?
Yeah.
What?
How many tickets do you want?
I can't.
Why? I just did.
No, it's too embarrassing. I won twice in a row, and that was it.
I just get back to the club.
No, fuck that. I'm not going to do that. You're late. It's okay. I didn't throw you out. But you're going to...
You got to dock my pants.
I will. I have to dock you. I'm sorry. Just in 10 minutes, all right?
How are you?
All right, good.
How's Long Island?
It's good. It's good, good. It was a good... no, it's not good, because I didn't catch any damn fish. That's the problem. No, I didn't catch any fish.
So Ray opened up his coffer somewheres and gave a bunch of stuff away?
Yeah, it was, you can get it. You saw on the thing. It's, I mean, you can still go there. You want to walk in the dark. It's in Hall of Honor, Wall of Honor, Wall of Honor, yeah. Go all the way, follow the signs, and it's on the left.
Okay.
All right. But it's just the, you know, ask him. Maybe he locked it up. I'm not sure, because it's supposed to be between 5 and 7.
I don't need any more stuff. I figured I would peruse.
Yeah, of course. Well, that's usually, I didn't need anything neither, but...
But you got something.
Yeah. Yeah.
It up very quickly. And I got more room at home now.
It's amazing. It's amazing. Yeah. And you always have good stuff, though. You bring good stuff to free.
I just pass the stuff on.
You know, you get to see the smile on somebody's face.
I know. I mean, well, it's funny that the TID radio, which is a nice little dual band HP, extra battery pack, rocket charger.
Did Neville pick that up?
Huh?
Did Neville take it?
I'm not sure who picked it up. I had bought it 2 years ago, played with it a little bit, and then I boxed it up, gave it to my ham radio club, and said, look, give this to a young museum.
Yeah.
A year later, they gave it back to me and said, we couldn't find anybody to give it to. And I said, you didn't try.
Yeah, that sucks.
You know,
yeah,
that kind of pissed me off.
yeah, indeed, yeah. Yeah, indeed. You don't have one of them.
No, but I was there the day he bought it.
Oh, yeah?
Probably my fault he bought it in the first place.
K-Town?
Yeah. It's pretty neat though. It's a lot simpler than the military one and the RCA one because you have to do all the punching yourself.
I wonder if Jerry Bordeaux has one.
Probably.
I don't know about that. I don't know.
Right on this one, they only test 5 tubes. Oh. Yeah, I know. It's for electrometer tubes. I like the one on the end. It's basically a full repair shop.
Right, especially the condition of it, it's amazing.
I think this thing is
Sounds
amazing.
are late enough that, you know, you're not just talking 4 and 5 pin tubes. But because Hickok had their patent.
Where's the ICO tube tester, the 625?
I don't have ICOs.
Well, I have an ICO. Here we are.
All right.
Paul, did he talk to you about insurance? Is it worthwhile or anything?
What do you mean is it worthwhile? It's $2,000 for the year, that's what it is. We are covered here, it makes us official at Info.
just did, yeah. Come on. I just got a comment from club member John Cummer that my microphone was turned off. He wants to turn back on. Okay, John.
Thank goodness.
Is it back on? John? Okay, good. He just nodded his head. Good.
I turned it off while you were talking about it.
Okay. All right, I just want to let you know that Aaron Hunter, okay, Aaron Hunter, one of our Southern Club members, he very kindly spent 2.5 hours in traffic to pick up this wonderful Norelco radio over here that we will be auctioning off after our presentation by John Stoll, okay? Gorgeous set, absolutely gorgeous. A gentleman named Mr. McCormick, I think his name was. He donated to the club. He wanted it to find a happy home, and it's a beautiful radio. So I'm sure this evening he will find a happy home. And again, thank you, Aaron, for picking it up for us at the club. Thank you very much.
You owe me.
I owe you. Well, as I usually say, you will get a high place in heaven for your efforts. Okay. All right, so we will have a drawing tonight of, wow, $45, folks, $45. So I need a volunteer to pick. Oh, I have a volunteer standing right here. A guy from Staten Island. Would you like to pick the winning ticket? No, I don't trust you to. Yes. The winning ticket is for $45. 1, 2, 4, 0, 4, 3, 9. 4, 3, 9. I see somebody scratching their head. 4, 3, 9. Oh, step right up. As we say, trust but verify.
I just printed it.
You just printed it? You got a combo? All right. 4, 3, 9. Congratulations.
Oh, thank you.
Thank you.
Now I can put more money on it.
Yes, you can. Okay. So we got that out of the way. All right, so again, this evening we have our very own member from Southern Virginia, John Stoll, to give us a presentation. So be kind to him. He hasn't eaten anything. He hasn't drank anything. He hasn't slept. He hasn't washed in a day.
We noticed.
But he brought some fascinating tube testers with him. So John, take it up, take it away, my friend.
Well, let's see, spare parts. Thank you for attending. You'll find out that I am no public speaker, far from it. I'm no wordsmith, but I did want to try and make this a different kind of presentation. This is not going to be an engineering exercise. There's a lot of reasons for that, but I do find that you can find a lot of misinformation on the web and so on and so forth. Have at. That's not my goal here. I want to instead do an overview. I know that there are people here who know a lot more about this topic than I do or ever will, but the idea is I did want to make this a level playing field for people to try and take a lot of the magic and nonsense out of tube testers. Let's see. Matt, please. No. Yes, please. This is a preceptor tube tester. It utilized various incandescent neon bulbs to indicate test results. I don't have the instructions, but honestly, I think that probably would be a little more reliable than some of the claims made by tube sellers on eBay.
Incandescent neon?
Incandescents and neons.
And neon?
Yes.
Neon.
Excuse me. He needed. There you go. Thank you. Yeah. I will talk about tubes occasionally. After all, we are measuring parameters, so I can't leave them completely out of the discussion. I will get into tubes when it is valid or necessary to make a point. And this is actually a tube tester. It's a CRT tester, but it's still a tube tester. Surprisingly, it uses a VTVM in the test circuitry. That surprised me when I took it apart and realized that. Do me a favor, Tab, please. All right. Up, please. Yeah. Yeah. Thank you. Basically, of course, with a tube tester, you're getting it for a reason. All right, so here are some of the goals that you would need to use a tester for. For shorts or leakage, because, let's face it, leakage can take a circuit and cause it to fail. You want to check for activity emission from the cathode. You want to check to see if diodes are in fact rectifying. You may want to have a gas test. There are those who want to measure tubes for gain. I'll just say that gets very interesting. And some tube testers would allow you to check voltage regulators. Oh yeah, Tab, please. Not everybody has a tester. In many cases, simple tube substitution will resolve issues for you. This can be the best test, as a tube tester cannot identify which tube will test well, yet fail in a circuit, like feeding a complex load, IFRF, or other things like a local oscillator. Tubes will test perfectly, and they don't oscillate. So one of the other things is that an experienced troubleshooter can look at the condition of the components around a tube and sometimes quickly identify what the actual problem is. So you don't need a tube tester in every single instance. Please. Yes, please. That's it, thank you. So what I will be discussing here are emissions type and mutual conductance types. I'm not going to talk about the Cardmatics or the others here. You will also have machines like a New London 901 or an RCA WT 100. They have great flexibility. But the research required to find and set the appropriate voltages and the connectivity for every tube element with those machines make them very complex. You also have regulated power supplies, and as a result, they're huge, they're expensive, and when you use them, everything is an endeavor of switches and dials in order to test the tube. So, you know, I'm not going to get into, you know, laboratory standard testers or anything like that. I am also excluding the computerized testers and the Cardmatics, as well as the European machines. Each of those actually deserves a discussion all by itself. There's a lot of features and functions that they have that you're not going to find in the classic tube testers. With that said, if anybody has a pristine New London 901 that they're using as a footrest in their, you know, maybe we can work out a deal. Tab, please. So let us discuss emission testers, which should indicate how much the tube cathode can deliver into a circuit, a crude measure of possible tube strength. Yes, that's a bakelite cover on that Simpson tester, and I just love, you know, that kind of style. In this, all the elements of a tube are tied together except for the cathode, and you test the tube as a diode, all right? Everything is based very simply on just, you know, the amount of emission that can be produced. There's a related category to emission testers. Dynamic emissions was the term, you know, invented to describe it. Samples of this would be the Precisions, like the 1012, the Jacksons, well, this is a 648S, and so on. The elements are not all tied together here, but various AC voltages are impressed on all of the tube elements. The tube is still operating as a rectifier, and the meter is reading the plate current. It does not give you any measurement of gain. It is, again, an emission tester. Note that the tube socket module has connectors on it over here. With the 648S and the 658, you have a Cinch-Jones connector. That tube island is reversible, and on the other side, you will find the old radio tube connectors, the 4 or 5 pin, you know, 6-pin connectors. So it's very convenient. It's very compact. You don't need any other external hardware or anything like that in order to test almost anything you can come up with. A more advanced class, it would be the mutual conductance testers. This is a Simpson 330. You may have noticed the switches are different. This is actually a mutual conductance tester. Appropriate voltages are impressed to the tube elements. A grid signal is fed to the tube grid, and the resulting plate current gets measured. The meter is marked to yield results. However, please note, if you can, that it does not give you micromhos. It's actually indicating a percentage, whatever that's supposed to mean. Let's see. Okay. The number everyone looks for from a mutual conductance tester is the micro-mho. Ohms measure resistance, mhos measure gain. And here it is where everything goes sideways. There are several different measurement methods for measuring gain. The different measuring methods yield different results. Tubes have characteristic curves by design, yet if you use different voltages or methods, the tube is now operating on a different part of its characteristic curve. Shifting the testing operation point on the curve will produce different results. Direct comparison of test results between different models often fails. Every American machine I worked on used some sort of AC input to the grid, measured the plate current, and that's called a grid plate test. Your gain figure, measured in micromhos, is the plate current divided by the grid voltage. All these tests require adequate filament bias and plate voltages, but none of the different manufacturers used identical voltages. As a result, you're getting a mismatch now when you try to compare results from machine to machine. Other machines used a method of testing called grid shift. Perfectly valid results, but never going to be identical to each other. Now, let's deal with the fact that tubes are inherently nonlinear devices. True, there will be an area of the tube's characteristic curve where it is fairly linear in operation, yet few testers operated each tube exactly where it needed to be in order to act in a linear fashion. Complexity and cost containment were also major factors. I fully understand why people use micro-mho readings. There's a real need to sort out high-hour tubes or tubes substantially out of the curve mean averages. What you cannot do is take a tube tester's mutual conductance number and mentally translate that into some sort of magical gain in a circuit. Micro-mho readings are given in a 4 or 5 digit accuracy. That number is derived from the ratio created by the tested tube and also a product, as I said, of the testing method. So direct comparisons are very often not valid. Results will be close, quite close, if the different machines have been recently calibrated according to their respective designs, but do not expect them to ever be identical. There is no guarantee of how well a tube will do in any given circuit topography. A load resistor and a meter will not emulate a complex impedance load. It is worth noting that different models of mutual conductance tester from a single manufacturer will not produce the same test results. Results will be similar, but do not expect them to be identical. Take a tube, test it for mutual conductance on, let's say, a Hickok 539, which has multiple ranges. It's one of the best machines you can obtain. And as I say, test that tube and switch from range to range, and you will find that the same machine with the same tube is giving you different results on the different ranges. There are limitations here. So let's talk about the things we're testing, the tubes themselves. If you pour through the documentation produced by the tube manufacturers, you will understand quickly that the published information is based on thousands of tube samples. Every tube type exhibited variations. These variations were generally of little to no consequence in most tube circuits, but every once in a while there was a special case. This also means the point of acceptance or rejection is not so absolute because of this normal variance in the tube operation. After manufacturing, all these tubes were, how can I say it, above or below the mean average. And as a result, you always had variation. Also, tube manufacturers never produced figures for emission or merit. They never ever documented that kind of thing. So tube testers were sort of left out, to figure out their own method of indicating what was a good tube and what was not a good tube. To expand upon this a bit, I cast about reading a lot of books and papers over the years. I found several interesting statements in a book written by a person using published tube curves by GE, and his work was technically reviewed by an RCA employee. This manual was created to allow better tube circuit design and performance based on additional plots of data overlaid on the original curves. Quoting from this conductive curve design manual, published in 1958 by Ryder, the author, Keats Pullen, stated, because of normal manufacturing variations, the positions of the contours may vary from tube to tube as much as 20%. Another quote, the wide variations result from minor differences in brand design and changes in design during production. A key quote, curves prepared directly from published characteristics given by one manufacturer will often not apply to another brand, particularly in uncontrolled areas. Very low plate voltage, very low screen voltage, near zero grid bias, and near plate current cutoff in particular. Those really are a lot of the failure points of many tube testers. Why all the vagueness? The different manufacturers did not use the same concentrations of metals, minerals, and so on in their respective products. To manage profits, manufacturers would make changes to existing tube design during the production run. Tests themselves changed during production. Some tube specs also changed as manufacturing technique improved, such as greater plate current or less leakage between tube elements. So the specs changed during the manufacturing of any tube. Please. Thank you, Matt. Tube testers sold to techs and hobbyists really are a box of compromises in order to provide people with a device that could test the most common tubes fairly quickly. Grid bias voltages changed from like negative 40 volts down to a few negative volts. Grid drive changed from volts to tenths of a volt. Plate voltages change from like 45 to as much as 450. That's what some audio output tubes were driven at. Grid drive, oh, sorry about that. Tester manufacturers created machines that kinda, sorta, mostly created a test environment for different categories of tubes. RF and IF tubes expect a high load resistance. 250K, a couple of meg. The load for 4 different common audio output tubes used in classic radios, such as the 6F6, the 6K6, the 6V6, and the 6L6, the loads go from 12.5 K ohms to 2.5 K ohms. It wasn't economically practical to create a test machine that could meet all these cases. And I'm only speaking here of audio amplifier tubes. This forced manufacturers to create a fudge factor so that tubes would test well regardless of the type of tube and the load that they had to apply. In very few models of tester can tube matching be done, and this is key. In push-pull circuits, tube matching is the only way to go, and I am not talking about matching micro-mho numbers. Tube matching starts with measuring the quiescent current drawn by each tube and then finding tubes with a similar current draw. The tubes should also want the same bias voltage to yield a very similar plate current. That's just the start for tube matching. And this is not accomplished merely by finding tubes with similar transconductance numbers. Very few testers allowed you to actually monitor plate current or allowed outboard metering to check the plate current. And that's required, again, for you to figure out exactly what your micro-mho reading for a tube is. Sorry. Of note that since a single unregulated power supply is most often used regardless of brand, applied voltages may or may not be really proper for every particular tube under test. A lot of older mutual conductance testers had perhaps one or two fixed overly high grid voltages to cover all the tubes. As tube design significantly advanced, lower grid voltages were required for proper tube operation. All of this means that tube testers often tested the tubes at significant disadvantage to the tube itself. I will give you my personal feeling about this. No tube tester can identify a good tube. It can only find bad or flawed tubes. Every single tube tester design has weaknesses. Tube testers do not place a tube under conditions that are similar to those in an actual circuit. Tubes were often treated badly in order to yield meter readings. There's no amplification occurring in emissions testers, so the current flowing through the tube has to drive the meter directly. Significantly, a load resistor and meter do not appear to a tube like the complex impedance that a real-world circuit does. For the service tech or the hobbyist, we usually do not need to test a tube to factory-level specs. Patents of test designs ensured that different manufacturers created somewhat different methods of testing so that you cannot directly compare the test results. Are the different machines using similar plate voltages, bias and grid drive, metering methods? Some testers use scales of 100, others use scales of 120. What does any of that mean? You can compare pass and fail indications, but past that, you really can't draw much from trying to compare tests from one tester to another. Looking at the published tube data in the well-known RCA tube manuals provided not only the target specs, but also curves. The big question then is how far away from the curves are the voltages and currents supplied by the test equipment? The answer to that question, often a lot. If you break out a meter and check the voltages your tester uses while testing a tube, you will find that the voltages used are not representative of the real world. I have one emission tester that uses 22 volts on the plate. Another I have uses 29 volts, and a third uses 156 volts. And that's all to test the one tube type, a 6V6. That tester is the one that's in the ASM 3U field kit. This photo is a Weston TV4. This is the one that uses 22 volts on the plate. The results are very valid, but like I say, it's not using real world volts in order to provide you with test results. Let's talk about specifics for emissions test equipment. A tester needs to identify any shorted elements. This is an absolute. Never go further in testing if a tube suffers a short. Some apparent short indications are acceptable, as very often there are elements in a tube that are connected internally. You will see that, though, in the chart, the information provided by the tube tester manufacturer. Leakage is a related test. A high impedance appearing across elements will not show up as an obvious short, but will cause a circuit to fail. Emission devices tie all the tube elements together, as I mentioned earlier, except for the cathode. Voltage is applied to most or all of the elements, and the tube is tested as a diode. But this category of tester can and will damage tubes. A straight emission test causes grid current to flow, since all of the tube elements are tied together. This photo is of a Precision 1012, popular as it allowed much flexibility in testing new tubes as they were added to production. Data was added as time went by, as the data was then supported by Coltronics well into the 1960s. Coltronics manufactured an outboard adapter which allowed newer tubes with different bases, such as compactrons, to be tested by the 1012. That adapter could also be used, I believe, by the ICO 666 and other tube testers. Of note, very few tubes are designed for grid current. I found this out many years ago myself by destroying a new old stock portable radio tube with a 1012. I held down the merit test button while writing down the test results. And in that 7 seconds, the tube was permanently damaged. The Radiotron Designer's Handbook, 4th edition, actually limits emission tests to 3 seconds in order to avoid grid damage or destruction. To highlight this, a moving coil meter may require a milliamp or more in order to move the needle. Most tube grids were designed to handle a few microamps, not milliamps. Recall that the grid is the closest element to the cathode and carries the vast majority of current in an emission test. You can't tell the grid to get out of the way. I will now refer again to the Radiotron Handbook, page 94. I am paraphrasing for clarity. Because of the very high value of emission current normally drawn from the cathode and the resultant excessive dissipation of the inner grids, the emission test is a damaging test and should be performed as seldom as possible and then always carefully. With that said, this is actually a very decent emission tester. I still have one, I still use it regularly. There were better emission units that had 2 transformers, like the Jackson 648 series. One of the transformers was for the filament supply, and the other provided the plate and grid voltages. The goal there was that the extra transformer actually gave you better consistency in tube testing. As you went from tube type to tube type, you didn't have a tremendous amount of voltage sag. Mutual conductors are completely different in the way they do testing. The description I am now going to give is a greatly simplified explanation of the Hickok style of measurement. Hickok used a bridge type of metering circuit inserted between two plate power supplies, and from those plates power supplies, you had the tube feeding the meter, which was designed to read DC. It read 0 in the absence of grid signal to the tube itself. As the 60-cycle AC grid signal was then applied to the bias tube, the tube output would now shift the bridge. This would cause DC to flow through the meter. That's a very gross simplification of the circuit, but it gives you an idea of how it functions. And when the patent expired, the numerous other firms copied the circuit. Weston, Simpson, and Triplett did it differently than Hickok. Weston used a 5 kilohertz grid signal, and the measuring method was basically the plate current feeding a tuned circuit, which then fed the metering. What that meant is that inter-electrode leakage in a tube would not affect GM readings. With a high-frequency grid signal and a 60-cycle filament voltage, the two were significantly different, and as a result, if you had any issues with the tube, it was filtered out, and you would see only the high-frequency signal in the results. The Weston also used a 4-position grid drive switch for the grid level, and that actually gave you a lot more consistency in measuring tubes in comparison, let's say, to the Hickok, which used a potentiometer. This design was kept alive in the Heathkit TT1 when Daystrom purchased Weston and then later Heathkit. I showed a picture of the Simpson 330 before. That utilizes a 2.5 kilohertz grid signal. I thought that the 335 and the 330 with their bakelite front panels is so much better than, you know, the metal. Triplett in their 3423 and the 3444 mutual conductance testers used a 4 kilohertz grid signal, again, as opposed to Hickok using 60 cycles. This is the Triplett 3423. It was not the best mutual conductance tester, but it actually was better than many mutual conductance models. This had an automatic grid bias circuit to better suit output current in metering for different tube types. What it was trying to do was, I believe, shift you to a better spot on the tube curve for much more accurate results. The point, as you've heard me make it before, is that mutual conductance tests between the different manufacturers, you can only use that as an indication that the tube has gain. You can't compare the gain figures from manufacturer to manufacturer, or even model to model. All of these designs, though, the Weston, the Simpsons, the Hickocks, they all had unregulated power supplies, and therefore the mutual conductance figures could easily be impacted. A single power transformer would cause voltage sag with high current tubes. This photo is the World War II era I-177A. This is clearly an outdated tester. This uses 5 volts grid signal when testing tubes. with a 5-volt signal, a small signal tube like a 12AU7 would be driven from saturation to cutoff. You're turning the tube into an on-off switch. You know, that's not really going to yield you too much information. It's perfectly valid for, you know, 4, 5, 6 pin tubes and tubes of the era when it existed. But at this point, that's not adequate for more modern types. This is the adapter that goes along with the 177. Because of the extreme high grid signal, though, the 177 is not a machine that you can modernize. Here is the Seco 107 that I have over on the table. This is a mutual conductance machine for only certain tube types. Other types are tested by the emissions method. There are no givens here. Every manufacturer and every model family had their own way of doing things. The late Alan Douglas wrote a book about tube testers and other electronic gear. This was published by Sonoran of Chandler, Arizona. Highly informative, highly recommended reading. He was a lifelong engineer designing and building oceanographic research equipment. In his book, he did a full-blown comparison of 7 Hickok models and found only 3 of the models came close to a laboratory tester's results for mutual conductance. He used a random 12AX7 for his testing and also noted how the random tube deviated from the published characteristic curves. Recall what I said earlier about tubes and their variations. Now, I'll talk about tube testers in general at this point. One of the things in a tube tester, especially older units, is the meter. You could have had a bad tube that caused the meter to pin, you know, full scale or something like that. The meter might have lost, you know, strength in the permanent magnet. You know, remember all these machines were built for a price point, so very often they did not use the most high quality material. Let's see, that brings me to another note. I've seen people who have put digital meters in, replacing analog meters with digital meters. I purchased several pairs of identical meters for evaluation, and I found that none of them agree with each other. If I bought a pair of voltmeters and put them in parallel, I got 2 different readings. If I had 2 ammeters and put them in series, I had 2 different readings. I don't care how many digits are lit. If you're using a digital meter, if they can't agree with each other, then it's nothing more than eye candy. You really have to spend money if you want a decent meter. Also note that analog meters have a resistance that is designed in as part of the measuring circuit. You can't just pluck a meter out and stick any, you know, any old meter you've got laying in there, or laying around in there. It's really designed to match. All test equipment needs to be periodically checked. Just when you thought it was safe to get into the water, you need to understand that tester manufacturers very often did not publish schematics. And all manufacturers made revisions during manufacturing without ever changing the schematic if it was ever originally supplied. Any schematic, even if it was supplied with that machine, is to be treated as no more than a suggestion as opposed to a final document. Over and over, I have discovered sections wired differently even different components and values. Never assume anything in your tester matches the schematic. You can dive in as long as you document things well first. Pictures from several angles and covering small sections overlapping each other are always a boon, regardless of what you're working on. Focusing here on the classic machines, you will not find any new Jacksons or Hickoks. The testers out there are all used, often tired, perhaps abused. Lift the cover and, inspect it yourself. Look for a more modern resistor, capacitor, or the like that will indicate that hands have been in there. And rarely does somebody flow solder as well as the factory employees did. You ever hear of cold solder joints? What if the front panel is missing screws? Expect the worst. Even if a benign repair, such as swapping out a bad tube socket, has occurred, that tells you to go over things carefully. A carelessly used hot soldering iron can easily melt wires and fry components. There are other items that need to be checked. Very often, load resistances have been damaged by bad tubes. They could have been cooked and are now way off. Other carbon comp resistors could have drifted. Most testers also used wax caps, which are no longer anywhere near their original values. And don't forget the lowly neon bulb, often used for shorts indications. The strike or turn on voltage of the neon needs to be tested, as old neons often require a higher voltage in order to trigger. There are different types of neons. You really need to check the specifications for the type of bulb that is in your tester. This series resistor, the current limit resistor for the neon, also needs to be checked. If it's drifted high, your shorts indication will not come on until it's way too late. You can use a simple resistor to test the shorts indication. Set up the tester for a 6V6, put in a test socket, wire up a resistor, a 100K resistor, for example, from pin 5, the grid, to pin 8, the cathode, and you should see a shorts indication. If you start experimenting with resistors, you can then find the sensitivity of your machine's test light. And that's actually a quality thing to understand about your machine. Some tube testers do also provide a gas test. To vastly oversimplify this area, think of gas as contamination in the vacuum. Electrons boil off from the cathode, striking the free-floating suspended contamination. This creates two flows. First, electrons are knocked free, and they're now flowing towards the anode, increasing current, but that's not controlled by the grid. Second, the contamination has lost electrons, turning it into ions, and the ions will now start bombarding the cathode. Both of these actions are detrimental. Gassy tubes need to be disposed of. Tube testers need some love. Keep the tube sockets covered or the lid closed. Air isn't just dust. It often contains a bunch of nasty chemicals leaching out of the things we have in our homes. It will interact with the switches, contacts, and sockets. Testers can seem like a black hole with a million wires. However, they remain a mix of a few building blocks. A power supply, tube sockets, switching of loads and voltages, and a meter circuit. In the simpler testers, the tube sockets are just wired in parallel. Something doesn't work? Break it down mentally. Pull a tube and break out the RCA tube manual. Can't test a 7-pin tube? The 4-pin tube socket will have the grid signal, the grid voltage present if it's working. Same with the plate voltage. So the idea is you can easily start to troubleshoot a problem with your tube tester. To illustrate this, I can mention a flaw which occurred to me in one of my Hickoks. My 532 would not test a certain 9-pin tube. I thought about it a moment and then grabbed a similar octal type. I had to do some mental gymnastics and get out a tube guide, but I did, and the octal then tested fine, which told me the power supply was working, the metering circuit was good. It led me to understand, without even opening the front cover, that already a good portion of the machine was still functioning properly. When I replaced the socket, as you can see, I went to actually unsolder the wire, and the whole metal tab came out of the socket. It was broken inside, and that's why it was intermittent, but it was only when I actually went to replace it that I discovered the exact problem. Cleaning. I love deoxit, but I will tell you not to spray it onto tube sockets or in switches. Used sockets will have minute pieces of metal in them due to repeated tube insertion. Bugs, dirt, and other assorted garbage is also in there. Now flood all that stuff with any cleaner that's got lubricant or other chemicals in it, and you can create sockets that now have a permanent leakage across elements. I recall from many years ago the original Kaeg solution called Cramelin, which was designed to turn oxides into conductive material so switches and contacts could function properly. The solution was to be vapor deposited, not sprayed or painted on. That led me to understand how a cleaner or other treatment can contaminate whatever it is applied to. I use the liquid deoxit on dental brushes, as you can see right here, to clean the tube sockets. Switches, I'll use some liquid deoxit applied with a toothpick. I will use a Q-tip at times to try and swab up a lot of dirt on switches, but the cotton swab often leaves strands behind, which will prevent the switch from properly working. Just ask me why I know that. Most switches are manufactured with phenolics, which are also very absorbent. Spray so-called cleaner in there, and the switch is now possibly conductive between switch contacts, leaving you with permanent leakage resistance. Some Sencors and the Mercury 1000 tester I showed earlier use a compact rotary switch that has some sort of plastic shield behind the switch elements and between sections of the switch. Get some of these spray cleaners in there if you're not careful, and you're never going to clean it out of that. You're not disassembling that kind of switch to ever clean it. Other chemicals you would try to use to clean it out will melt the plastic itself. Remember, Sencors have a 100 meg leakage sensitivity, so it's easy to find how these things can occur. Apply the cleaning solution, be it alcohol or deoxit, on whatever you're using to wipe the contact clean. Then remove as much of that as you can. Pipe cleaners, Q-tips, dental brushes, foam pads. Like I say, all of those things have worked well for me. The foam pads on the stick, these are triangular pads, pipe cleaners, any of this stuff that can absorb and swab off debris is to your benefit. let's see. This was a switch inside that Mercury 1000. It was not operating when I purchased it. If you squint carefully, you'll notice that the lever switch has 3 rivets and a screw. I hand drilled out the phenolic and the 2 metal tabs. Oh, that stunk. But like I said, I hand drilled it out and I had a very small screw and nut, and it's been working fine ever since. What would happen is, as the switch rotated with the bad rivet, this would actually pivot out of the way and never make significant enough connection for you to take a mutual conductance reading. Don't test tubes with crappy pins. Whatever corrosion or dirt is on the pins does not need to be scraped onto the contact surfaces of the socket or into the tube socket housing itself. I did have a hiccup current. Triodes have much lower plate resistance, say several K, and then pentodes that will appear as hundreds of K or a meg. An older tube can appear to have higher gain when tested than it really can produce in the real world. Do not ever expect tube testers to agree in their numerical values. That's sort of like religion and politics all rolled into one. There are very good reasons for you not to expect, identical values from various tube testers. First of all, testers were manufactured with parts having tolerance values that the manufacturer found acceptable. 2%, 5%, 10%, you don't know. We will find that some manufacturers provided specs on a particular test, but not on the entire tester. A machine that was calibrated when Sputnik was floating around the Earth is not a unit I will consider accurate. Second, whenever a test device uses a potentiometer, setting that control again to the exact same setting that it was at some time in the past is not a given. Since some testers use several rotary controls, duplication of test parameters is often not achieved. You are adding variables on top of the machine's tolerances. Third, line voltage is not identical everywhere all the time. It varies during the day. The setting of the line voltage also sets all of the other applied voltages in single transformer designs. True, they are tracking each other fairly well, but rarely do you know the actual voltages applied to the tube unless you are tracking it with accurate external metering. As I said earlier, meters themselves are a problem. Have you ever tested it? If you want to test your meter, never ever use a voltometer. And some of the cheap digital meters also have a relatively low impedance, and they put out a fair amount of current in their lower resistance ranges. So you don't ever want to do that. If you do find that you have a defective meter or a tired meter, it's close but not good enough, there are schematics on the web which show the use of an op amp to drive a replacement meter. Low parts count, quite simple to construct, and the use of the op amp is to provide enough current to drive almost any meter that you can come up with. A proper op amp design adds a resistor that's equal to the meter that you're replacing. So this way, you're not changing the internal resistance and design, basically, of the tester. You can use a DVM to find the resistance by using it as a current device, but you have to use current limiting resistors. So you'll have a battery supply, you'll have a DVM acting as your ammeter, and then you'll have your meter under test. But like I say, make sure you have a clue as to the appropriate current limit resistors that you need. Another facet of all of these machines, there is no consistency between testers in the rejection or acceptance point of a tube. Even within the same manufacturer, some models had reject values and other models used the bogey value of the tube manufacturer. The bogey value was created by measuring thousands of samples. So that's what you would find listed in like the RCA tube guide and the like. As a result, the bogey was considered an average. The Weston 981 chose a reject point on its meter, and the value used by this model was 65% of the manufacturer's bogey value. For the Hickok 532, tubes were rejected when they fell 20% below average. Power tubes rejected when they fell 35% below average. You have to read the manufacturer's manual to know what model of tester is using what value, period. You can't assume anything. An interesting test on the 981 is that the Shorts test is actually measuring leakage. You'll notice the scale actually goes out to 10 meg, 5 meg, 500K, and so on. So you don't have a neon light, you're actually measuring it. Another nice thing about the 981 is that you had switches for the cathode, the plate, and the grid, and this allowed you to test dual section tubes very quickly. You didn't have to go through a lot of switch settings or so on and so forth. The toggle switches made it very easy to do. Some Sencors do significantly better than the Weston in leakage testing, being later designs. They offer something like 100 meg leakage testing because they're using FET amplifiers. So never hose down Sencor switches with spray chemicals. Often you will create a problem you can't fix. The Sencors also tend to use a lower plate voltage in their tests. For those who want to check to see if their mutual conductance tester is fairly accurate, grab a pair of meters and a test socket and wire it up. Now, what I did is one meter is set for reading the grid voltage, the other is set up for reading plate current. I used a relay socket because that allowed me to quickly configure the wiring for whatever tube I happened to use for my testing. This is also just a toroid to help try and kill any potential oscillations, because now I'm adding, like I say, a bunch of wiring which could really screw things up. But by taking my readings and doing the math, now I could see if my mutual conductance tester is actually fairly close in what the tester says the tube is doing. And again, because I'm adding a lot of material here, if a reading is like 500 micromos different, you know, from between the tester and my calculations, it's fine. That is fine. Actually, I can think of only one tube tester that would allow you to check values, and that is the TV2. But note that the TV2 does not read out micromos directly. You're back to a percent quality reading on the main meter, whatever that is. If you calibrated certain controls on the TV2, then you could actually start to get micromo readings. After doing the measurements, of course, you know, with my external metering, you know, you get your results, and now you could start to correlate things. Oh, by the way, the TV2, for all of the meters it has, there's no meter to actually measure the plate current. So even though you're looking at 6, you know, analog meters, you cannot check the tube's plate current. You have to get into external sockets and wires and so on and so forth. The entire goal here was to poke people into thinking. Most of the statements I've made are generalizations, and you can always find a flaw in a generalization. Almost no two testers are identical, so comparisons don't work. What I wanted is for people to stop thinking that these are magic boxes capable of all sorts of perfect definitions and numbers. The numbers are meaningless unless they're grounded in reality. Break out your meter, double check your filament, double check your line voltage, and so on and so forth, and make sure that your tester is actually doing what it's supposed to do. Let me go here. Before I finish speaking, I want to make an acknowledgement. I feel I have to, really. I've made references to the Radiotron Guide. Mine is the 4th edition, published in 1952. That edition is a compilation of existing and new data in order to provide the world with better information and fewer knowledge gaps. It also required more experimental and analytical work to be performed by many. The work was performed by those under the guidance of F. Lankford Smith for the Amalgamated Wireless Valve Company, Proprietary Limited, of Sydney, Australia. Even though the RCA meatball logo is worn on front, Amalgamated Wireless personnel and many engineers performed analysis and experimentation in a vast spectrum of areas. Over 30 people collaborated to create over 1,300 pages of information. The knowledge we use every day is truly us standing on the backs and shoulders of those worldwide who toiled tirelessly in the past attempting to expand the collected knowledge. So to them and others I am indebted and feel much admiration and thanks. At this point they're all sadly gone. The present firm is a completely different entity. Yet I wanted to recognize and thank the old boffins who brought people around the entire globe to a much higher level of understanding. Hats off to them. Thank you.
Q&A, guys? Q&A?
Yes.
I never owned a TV too. There's 6 meters there. What parameters parameters is that thing measured?
Well, the TV2 allows you then to start looking at screen voltage and other things. So, like,
So 1 meter was AC line voltage,
you know, let's go back. Like I say, you know, you do have the ability to set various things, you know, the filament, plate, and so on. So, but like I say, you would think something like that would have, you know, plate current listed so you can actually do the real deal, but not so. I have read, I do not know if it's correct or not, but I have read that the TV2 was a companion to the TV7. Just a side note, the TV2 was designed by Air King in Brooklyn. And Air King was owned by CBS. Go figure. The TV7 was to be used in the field, and according to what I have read, and the TV2 was to be used back in the repair depot. So the two, like I say, have a similar parentage, I'll say, but that's what it was all about. That the TV7 was, you know, again, the companion to this. Any other questions? Sir?
Is there any truth to the rumor that some brands of testers were designed to sell tubes?
Now, why would you ever think that some tube testers would ever be used for nefarious purposes? Yes, pharmacies and hardware stores very often had a tester, and if sales weren't doing all that well, there was a little potentiometer that the manager could crank a little bit and get things involved with. Yes?
Have you ever encountered a tube tester with an English switch on it?
Yes.
I actually bought one off the counter at a TV repair shop, and the owner was kind enough to show me the feature of the
Yes, yes.
switch that he installed on the back of the tester back in the 60s.
Yes, the accessory, yes, yes.
We thank you for that because we tell that story to people in the museum and then we tell them that we're not sure that that's true. Now we can say yes.
Yes?
John, I've kind of developed the bottom line on tube testers here. And this is an expression that I learned from my wife. She learned it from her mother. No matter which way you turn, your ass is behind you.
So true, Al. Although with some of these devices, I think it actually was leading. Yes?
John, I have a fairly ordinary emissions tester, and the meter, it's you know, red, yellow, and green, and it is also marked from 0 to 100. Every brand new, perfectly good tube I test on it reads 75 out of 100. Why do they do that? Why can't you say a tube is 100%?
The variation in manufacturing caused some tubes to have more gain than others. I have read about one tube tester, haven't verified it yet, but I read how one emissions tester was designed that 65% was the average. Above 65% meant it just happened to be a slightly hotter tube. Below 65%, that could indicate that you were falling down on the job, so to speak. 75%, yeah, that tells me the mean average of the manufactured tubes. The designer of the tube tester decided, I'm not going to do 100% because if the meter tries to go over 100, it will damage itself. So he left some room in there for variation. Hold that thought. Yes, sir.
Okay, a couple of things I think I learned today was, one, buying any used tubes off eBay or strange people who say they're tested doesn't mean anything because you have no way of knowing what they tested for. Second thing, my dad's method of testing back years ago of grabbing tubes out of a big box and plugging them into the radio until the radio worked was actually pretty good.
As I said in the beginning, you know, sometimes tube substitution is better because no tester ever can emulate really an active circuit. Darren first.
So, to add to what you said, and I think it's only fair to throw this in there. I've probably tested thousands of tubes over the years and worn out tube testers because I sell tubes. I try to be one of those people online who sells really tested tubes, calibrated, tested, better company. So what have I found? You could take a tray, a bulk tray from RCA that I have, okay, full of 100 factory fresh 1962 peak of quality receiving tubes. And what you're going to find is if you analyze them on a tube analyzer, no tubers. It's not like there's just no. So the tester, you asked about why new tubes. I've had new tubes that test barely above minimum, and I've had new tubes that test better than so. Testers, the best tester in the world. Tubes are brand new. They're
Yeah, you know, tubes are certainly not like a screw where you got perfect dimensions. Again, there was such a wide variation in manufacturing tolerances. The manufacturer, of course, you know, wanted to sell as much product as possible, but at the same time, very often, in the vast majority of situations, variations in a tube type did not cause malfunctions of a circuit. Your question?
Yeah, so given all these limitations of a tube tester, what role does it play to you, like when you're kind of like a piece of equipment that's malfunctioning?
First of all, the key to me is shorts and or leakage. If you can have leakage in a tube that will throw its bias off. You can have a tube that runs way too hot and now can destroy components in the surrounding circuit. So for me, and that's why I really remark about the Weston, it's shorts. It doesn't have a shorts test. It actually has a leakage test. And that allowed me right away to evaluate tubes, especially pulls from circuits. You know, a tube that's got some hours on it works fine, but it could have leakage. And at that point, it's got to go before you burn out an IF transformer or, you know, start cartwheeling around with other issues. Past that point, as I said, I use my Precision 1012, even though it's just an emissions tester. If I am purchasing tubes in, you know, the wild, so to speak, if I buy tubes from eBay, I actually have a little EMC. The thing is smaller than the dimensions of the paper. I'll use that little EMC strictly to ensure that no tube that I've purchased has a dead short. Once it passes that test, then I will consider putting it in one of the other testers, because at that point I feel like, okay, I'm not going to wipe out a machine, because you're not getting power transformers for these. You're not getting switches for these. The last thing you want is to put a really bad tube in a tester and, you know, like I say, melt the switch, cause a problem, and so on.
Yeah, so maybe you're looking for gross defects.
Yes, exactly. And then you know, you can use a tube tester to do some other things. You know, again, tube tester's got a power supply, and my relay socket allows me to quickly wire all sorts of different tube types up. And with that, now I can start looking at quiescent current. You know, you just apply the voltages to the tube and see what the tube is doing. Because there are times that I've been able to find that distortion in an audio amplifier was related to a tube that was fairly out of spec. It would pass in, you know, tube testers, but it wasn't happy in actual operation. And by using, you know, an ammeter, you can start to see, okay, this tube's drawing a hell of a lot of power, and it's not producing a hell of a lot. So, you know, where are we going with this? Yes, sir.
Yeah. Why PT Barnum?
It's one more every minute.
There's a circus out there.
There you go. That was generally my take was that Barnum was a great showman. Tube testers are great showmen. I'd like to know how many hundreds of thousands of tubes were sold only because some tube tester said that it was, you know, better than something else. And again, you know, no tube tester ever emulates a circuit. So they do have a purpose. They can serve you well, but you have to know its limitations. And, you know, learning your voltages in your tube tester is to me, a value.
You left out a photo of the old tube testers we used to have at the drugstore.
You test them? Yeah, I don't have one, so yes.
Okay, what Scott was talking earlier about the meter not reading 100%. It's an emission tester, so it's essentially no-go.
Correct.
You're 100, it's just like a relative reading. So if you're reading somewhere in the good range, you can compare to two. So one good beats 75, one good beats 60. So that the 0 to 100 really is useless.
No, understood. You know, you're doing a current test basically. You know, by operating the tube as a diode. You do a current test. That's only valid for that machine, but it's a general indication. Because unless you've checked to make sure that the filament voltage is correct, that Seco 107, if you put a 12-volt tube in it, don't be surprised if you're looking at like 10.5 volts on the filament. The transformer in it is very small. It's good enough to give you a generic indication, you know, that the tube is capable of gain. But like I say, it's no match for a real circuit.
The other thing about the English, I picked up the Hickok last year in Rochester, right? And it's 533, and I saw English.
Yeah.
So I read it, and it's essentially go-no-go. So if you go through all the trouble of reading micromodes,
Yes.
why do you put that English feature on there? It's a separate, you got to set a separate pot, go to English to read go-no-go, when you can just read the micromodes.
I understand what you're saying.
What's the purpose of it?
Guess your best. I can't tell you what the thinking was when they designed, you know, the go, no go versus.
Right, but it's a Hickok, it's not like a full stick or a crack, so why would Hickok do something like that?
I don't know. There must have been some sort of justification for them to do it that way, you know. No. Yes, sir.
Do you know if there was a specific tube type or category that the Navy TV4 was designed for?
No, if I understand it correctly, the TV4 it really is a Korean era type machine. So I feel that that would have been used in, you know, the radios in the field. And of course is why it was buried in that, you know, complete tool kit. Again, it was designed for a very specific purpose, military radios, and again, that kind of era. But past that point, you know, it works. And I have compared a number of tube testers together with the same, you know, thermionic bulb, and found that very often they're very close in their results. Not identical, but it's enough to convince me that the size of the transformer and the meter and the circuit inside, you know, the voltage drop and everything, current limiting, whatever it is, it works. And as a result, you can get by. I will say that the triplet, let's see, did I, there you go. This, I think, is one of the significantly better mutual conductance machines. Like I said, the fact that it tries to adjust the grid drive to get you into a better operating zone for the tube, as opposed to, you know, fixed values that may or may not adequately work. They're all boxes of compromises, every last one of them. Like I indicated earlier with the audio tubes. You know, you have audio tubes, and look at the 6L6. Look at the original 6L6 tube, and then look at the last one they manufactured, and the plate voltage is completely different.
I have a Mesa Boogie dual 6-pack with 12 6L6s in the plate service. And just to recap that, or even the max pushing the pulling, it's, you know, you spend more than a weekend playing.
Oh, sure, and I'm sure, agreed, but I'm sure if you stuck in, you know, some real old 6L6Gs, that they would last a good 5 seconds, you know, because they can't be hammered by a higher plate voltage. Yes, Darren?
It's fair to say that the variations in long-running tube types is enough for an entire presentation in itself.
Absolutely.
And it's one of the few areas where the hoopla and hype about I want that tube over that tube actually has relevance. Because, you know, the tube that I always go back to there is the 6L6.
Mm-hmm.
The 6L6G, which is the original 6L6.
Yes, yes.
Yeah, like the plate voltage, I mean, an RC, end of the run is the 6L6GC, specifically the RCA. You can beat the hell out of it.
Yes.
And there's equipment out there, usually guitars, that run those tubes almost to their limit. Put one of those shoulders, it kind of lighten up like the 4th of July.
Yes, yes. Yeah, you know, again,
And how do you test that? It's the same idea.
Compromises. You want something to you know, indicate when you've got a problem tube. And of course, when this was built, there were no Mesa Boogie amplifiers. You know, all of this stuff predates that. There were only a few testers, I think, that followed. You know, the computerized testers, and maybe one of the Cardmatics. I don't know the manufacturing dates of the Cardmatics, but the idea is the way tubes are used/abused in equipment predates this. So this can never, ever stress a tube like the equipment can. pure and simple.
Just quick
Yes.
question.
Yeah.
Why is the TV7 considered holy grail? The prices are astronomical.
Well, you know, what can I say, Bill? To a certain degree, yes. You know, the Hickok circuit was very elegant and simple. 2 plate power supplies, the meter in the middle, you put the tube there, there's no DC flowing until you give it a grid signal. All right? Everything's balanced, everything's neutral, everything's happy. Give it a signal, now you're getting to read the current. You know, what year was that patented in? You know, Job Bernhardt did that, you know, in the 30s. The idea is that it was a very elegant, simple design. It's outlasted a lot of other things. But, you know, why the 7? What can I say? Yes, sir.
Can I throw something out there about the TV7? And I'll bounce this off of you. I've always had an opinion about that tester. It's a really good tube tester for what it is. And unlike the 539s, at one point, especially back in the late 80s through the late 90s, there's more of them around than any of the other better Hickok models. And I think it incorporates a lot of the features of the better Hickok models. And I think its ubiquity of acceptance and desirability is simply because they're so bound. They were something of the standard because everybody knew them.
Yeah.
And you know, when the whole audio hobby, which is where the value of these tubes came from, was starting to really get big in the 90s, that tester is everybody would, oh, go get a TV7, go spend your $125. It was $125 from the Fair Radio catalog, a little more to buy it reconditioned from ABS. They were everything for the money back then, and everybody bought it. And I think the reason it's so ubiquitous today is because there's just so many around. The military released them en masse, I think, after about 87. And, you know, for so long, you could buy them so cheap, everybody bought them.
Yeah.
I think that's really what drives the
Could very well be, yeah.
It's also the easiest way to compare the numbers when you can't compare them against the model. If everybody has that model, it says that this is
Agreed.
what the dollar means and this is currency, you know.
It becomes the common denominator.
When you're selling stuff used.
Right.
Like I know what a 10 means on my meter, so if everybody has a TV7, it's as close as you can get to saying this is what it means to me.
Any other questions or observations? Yes.
Well, you got me thinking about the limitation of tube testers. An interesting story I had with a Emerson radio, the 41 Emerson Model 461 that had a 12 SB7, where the one of the 2 audio diodes wouldn't even move the needle of my tester. The other one was like well over into the hood. So what got started me to pull on all my tubes, even if they don't work in one radio. Because I looked at the schematic and I saw that the Emerson only used one of the 2 diodes. The other one it just threw away to get the output to ground. So I found another radio in my collection that actually tied the 2 together. I put that bad 12 SB7 in that other radio, and that's coming up 3 years later. Radio, I'm still using it.
Yeah.
And the other radio that works fine.
Yeah, again, you will find that certain tube testers certain mutual conductance testers would test one half of a tube for mutual conductance, and the other parts would only get an emissions test. Like I say, you really have to know your test equipment to understand what the test results actually mean. It's a lot more than just a wiggling needle, you know, back and forth.
In this case, the 2 really wouldn't work in the Emerson.
Yeah, right.
That's why I put in the test to begin with, because
Right.
I lost all the audio out of the radio.
Yeah. Any other questions?
How
Put a round of applause for this.
Oh, are you applauding for the cricket? I've been listening to him all night long.
Do you all agree that this man's a lot smarter than he looks?
It's all perception.
Yeah, okay, hold on.
All right, actually fantastic, actually fantastic. We didn't expect this, you really didn't. And again, for what you did to get up here from your home in Virginia, and all your traffic jams and never eating or sleeping or anything, we really do appreciate it. Well, I hope you're going to Staten Island tonight?
No. I'm staying in North Brunswick, which is close to Staten Island, but...
North Brunswick is closer. All right, a little closer. Well, anyway, you're not going back to Virginia.
No.
Thank goodness.
My son's birthday is tomorrow, so I'll be meeting with family and so on and so forth.
Right,
So,
that's great.
yeah. And, I have family up in the White Plains area as well, so this gives me a base of operation, and it becomes very, very convenient to get around.
Well,
So,
then we should see you more often then.
like hell.
You going to K-Town?
Yes.
Okay.
Yes. You can
See you
remove
at
that.
Kingtown. All right. Again, John, we really appreciate it. Thanks so much.
Well, maybe I'll learn how to be a public speaker and do better.
You did just fine, just fine. All right, folks. We have this fantastic radio over here, this Norelco. We're going to auction it off, okay? And what we're going to do, John, if you have a second or you have a few seconds, you'd like to explain more about your devices there, welcome to do it. The D of JD Auction Services will now perform his magic on this Norelco radio.
Why is Phillips made for the Americans? Because this little company out of Philadelphia called Phillips sounded too much like Phillips. So they
It'll shut about it, so it takes a minute. Well, the YouTube video will not end well.
Right? It's supposed to relate to North American Phillips. It's still around today. It will only this day. All right, so somebody had to go through a lot of work to get this, I understand.
Yes, Aaron Hunter, wonderful man.
So let's try to make it worthwhile. This is a beautiful set. I hope it hasn't been plugged in.
Okay, so I reconnect.